Hi everybody, welcome to your very last play posit of semester 1. Can't even believe it. We're going to be wrapping up unit 6 and just reviewing a little bit. And before we do that, just a reminder that your math and reading STAR 360 assessments are due by the end of the day on 12/21. Make sure you get those 2 assessments done before you head out for winter break. Those should be the only things on your plan for the 20th and the 21st. And if you're watching this, hopefully you're watching this on Thursday. That's when it's intended. I'm sorry, Wednesday the 15th. So you do still have time this week to get your exam in if you're taking your exam. That's due by the end of the day on Thursday. This should say 12/16. I never did fix that from the last time. Don't forget about doing your practice exam. I will just ask for your patience because these 2 items are in USA Test Prep, and USA Test Prep is an external site from our OMHS, so I manually enter those grades in. So I usually do it daily. If you would like your grade entered in sooner, you're welcome to send me an email and I can get that updated for you. Our end date is this Friday, so make sure you have no missing assignments and to do any of those retakes that you want. We do have office hours today, Wednesday, and reach out with any questions. I'll be in office all week. So the very last bit over here, you can see how many slides we have. It's not that many. Of Unit 6 are some similarity postulates. Do you guys remember we had triangle congruence postulates? Things like side, 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 and side, angle, side. And remember all these? And hypotenuse, leg. And those were for congruent triangles. Well, we also have them for similar triangles. So I bet if you looked at number 1 here, this first image of these 2 triangles, you could tell me the similarity postulate. Look at what's marked on the triangles. If we label it, we have an angle and an angle. An angle and an angle. This is the angle-angle postulate. I really should say similarity postulate because there's so many postulates, right? This is the angle-angle similarity postulate. How about this one? What do we have marked? We have a side, and a side. This is the side, side, side similarity postulate. And this is when the sides are proportional. You can see that these sides are not congruent, right? Because they're not congruent shapes. They're similar shapes. So remember when we learned that shapes are similar, it means that their sides are proportional. So we could do 20/10 and 14/7 and 12/6. And these are all 2. So see, they're proportional. They all equal the same thing, so they are similar. Am I saying that right? Similar. Why does that sound funny now? Try it. Say it out loud. Similar? Similar. Not similar, it's similar. Oh my goodness. All right, here's the last one. We have a side mark, an angle marked, and a side mark. So this is the SAS similarity postulate. These are the only 3 similarity postulates. There are no others for now. But the beautiful thing is you kind of just see what you have marked. So let's try some. Determine whether the triangles are similar. If they are, write a similarity statement. All right, so we have a 90-degree angle and a 90-degree angle. So remember, we have an angle-angle, a side-side, and a side-angle-side. Those are the 3 similarity postulates. Now, these 2 angles are not equal, but let's see if we can find the third. We know that this all adds up to 180, right? So I am going to grab my calculator just to be sure and basically we could just do 90 minus 47, right? Since this is already 90, we know there's just 90 degrees left. So this is 43 degrees. So in fact, this would be 47. So we have 3 angles marked, but we know that we only needed 2. So these are similar by the angle-angle similarity postulate, and we can write that similarity statement. Triangle ABC is similar. We use the little squiggle this time, not congruent, just similar. We want to match them up. So A was the 47, so Z is the 47. B is the 90, Y is the 90, and last we have X. So we do want to make sure that those letters match up and correspond to the congruent angles. Let's look at this one. Let's see what the missing angle is. So we would do 180 minus 35 and 73. And here I get 72 degrees. So over here, obviously, they're not going to be congruent, right? But let's see what this angle is. I'm sorry, similar. 82. Let's see, do we have two angles that are congruent? The answer is no, we only have one. So these are not similar. Not similar. And not having at least two angles congruent would make it so the sides were not proportional. We always talk about how the angles really affect the sides and vice versa. Determine whether these are similar. So we're just going to keep practicing. See if we can match it up to one of those similarity statements. So here we have a side, an angle, and a side. Side, angle, and a side. Let's see if the sides are proportional. So we could do 3 over 16 equals 4 over 12. And this is the reduce. Whoops, let me do that again. Let me erase this because I matched them up wrong. So I want to do small over small, 3 over 12, and big over big, 4 over 16. There we go. So this is, we can divide both of these by 3, right? 1/4. Divide both of these by 4. 1/4. We do in fact get the same ratio. These are proportional. So by the side, angle, side, similarity postulate, these triangles are similar. So we can write a similarity statement. So we could just do triangle J, it's funny, there's an A there. That must be angle A. JLK, oh, it's triangle A. JLK is similar to triangle. So J is, so this is tricky. It matches up with the Y. Okay. Y and then X, Z. There we go. The long side is XZ and the long side is LK. So we're good. All right, how about this one? Let's find that missing angle in both of these triangles. So I'm just going to do 180 minus the angles that are there. And here I get 50. Let's see what the other triangle gives us. And I get 45. So sure enough, we do have at least two angles that are congruent. They're all three congruent though, right? When they're all three congruent, do you remember what it's called? They all have to be the same and then it would be equiangular. So if they're all three angles are congruent matching up to the two triangles, it does not have a special name. So let's write the similarity statement. We could just pick any order if you want on the first one. JLK is similar to, and then we'll match it up. So J is 45, Y is 45, L is 85, X is 85, and then Z. Determine whether these are similar. All right, we got another side, angle, side happening. So we just need to see if the sides are proportional. So we'll do over the height or small, a big over big, and then the base over the base or small over small. And we can reduce this, or you can even grab your calculator if you want. Like if I just did 10 divided by 18, you get 0.55 repeating. And 9 divided by 16, you get 0.56. So these are not proportional. They're not the same. So these are not similar. All the time in geometry how things can look a certain way, but they're really not all the time, so we have to use the math to back it up. So a really powerful tool with similar triangles is to be able to find the length of things that you wouldn't really be able to find easily in real life. So here's a cell tower. It certainly looks very large when you look at this height being 3 meters. Let's say this is you. You're standing here. 3 meters. How many feet are in a meter? I don't even know. Is it 3? Because I think of a meter stick. Let me look. How many feet in a meter? Oh, I'm thinking of a yard. There are 3 feet. Yeah, 3 feet, 3.37 inches. Interesting. Okay. So yeah, this could be a person. That's relatable. And you're looking up at this cell tower and you want to know how tall it is because a phone company needs to know. So it decides to use a 3-meter pole actually. The pole casts a shadow by the sun as shown in the diagram. Both shadows end at point B. So the tower is casting a shadow and the pole or the person holding the pole is casting a shadow. We can form 2 triangles and both of these are perpendicular to the ground and then they share angle B. So if you wanted to, we could draw 2 separate triangles, the tower triangle and the pole triangle. I know in the diagram they're drawn together because they're casting that similar shadow, but sometimes it's helpful to pull them apart. So the pole is 4, the tower is 40. Be careful, make sure you add up the whole thing. And this is 90, and this is 90. So we know they are similar by the angle-angle similarity postulate. They both have 2 congruent angles. So because they're similar, it means they have proportional sides. So we can set up a proportion. That's 3, right? So we're trying to find the height. We're trying to find this missing height. Look at how we can set up a proportion and solve it for the height of the tower. So it's kind of up to you. There's a few ways you can do it. We could do x over 3 equals 40 over 4. And then we did review how to solve proportions in our last play posit, but I personally think it's easiest to cross multiply. So 4 times x equals 3 times 40. So 4x equals 120, right? And then we'll just divide both sides by 4. So the tower is 30 meters tall. So instead of having to find something that's almost like over 90 feet tall to actually measure it, could you imagine taking a measuring tape and trying to measure this cell tower? No, we can use similar triangles to help us find the height of really tall things or things that are really far away. In real life, not just phone companies, but also surveyors, land surveyors. My dad has a device that actually surveys the land that he's going to build homes on, and he can find the height of trees many, many miles away. He can find the height of mountains. It's really cool. So there are various uses for these similar triangles in real life for sure. So here's another one. The diagram shows an 84-meter building. And then there is a flagpole outside. The shadows of the building and the flagpole both end at point C. So that means this. What is the height of the flagpole? So it's funny. I don't feel like we would ever know the height of the building over the height of the flagpole, but it's possible. And maybe we need to replace the string on the flag, so we need to know how much string to get. My stepdad actually uses this information in firefighting. They know typically how tall the building's going to be, and depending on what building they drive up on, that might be in flames, will depend on the size of the ladder that they choose. So it totally works. So let's find out first if the triangles are similar. They both share this angle and they both have a 90 degree. So they are similar by the angle-angle similarity postulate. Identifying the postulate means that we can now set up that proportion for similar triangles. So we could do height over height, x over 84 equals the base of the little triangle over the base of the whole thing. So that's 11 plus 45, 56. And then just cross multiply. So 56x equals 84 times 11. Let's see. I'm going to grab my calculator. You should too. 84 times 11 is 924. And then we'll just divide both sides by 56. And we get 16.5 meters. All right, so I do have a Kahoot, and I'm going to set it up so you guys can do it on your own if you wanted some more practice. So I'll put the link in this play pause it so you can click that and it'll offer you some more practice if you want it. And I hope that you guys have an amazing winter break. This is my geometry, get it? I know that not all of us celebrate Christmas, so I did just want to share one of my favorite sort of holiday-ish memes with you guys. I do hope that whatever you're doing over winter break, you find some rest and relaxation, some time to do things that you can't always do when school is happening, even if it's just a hobby like reading more books or playing more video games. And I cannot wait to see you guys in the new year and move on to semester 2 with you. We have a lot of fun things planned, a lot of really cool things to learn about circles. And I'm being honest, circles get really interesting. And the year is just going to fly by. So I don't want to get too emotional. I'm really looking forward to working with you guys for the rest of the year. Continue to reach out if you need anything. And I will talk with you guys soon. Bye, everybody.